Hello, my name is Alim Syarif. I'm from the Department of Chemistry Hasanuddin University. In this video, I want to show my simple research that focus on the using of computational chemistry. In my research title is Molecular Docking of Indazolide alkaloid from seeds of the Nigella genus as potent HIV-1 protease inhibitor.
Acquired immune deficiency syndrome is a set of symptoms of disease that arise due to a decrease in immunity caused by HIV infection. HIV is a virus that attacks white blood cells that cause a decrease in human immunity. The current treatment of HIV infection is using antiretroviral therapy. One of the mechanisms of action of ARV drugs is by inhibiting the work of the protease, an enzyme which plays a role in the maturation of the virus. Inhibition of protease enzymes has an impact on immature virus so that virus become non-infectious forms. Therefore, protease enzyme can be an ideal target for the treatment of HIV disease. Nigella seed extract is reported to have activity as an inhibitor of the HIV-1 protease enzyme. In this experiment, molecular docking was carried by indazole type alkaloid compounds from the seeds of plants of the genus Nigella to determine its potential as an inhibitor of the HIV-1 protease enzyme. This experiment begins with the preparation of the structure of enzyme and ligands, then validation with the redocking protocol. Next is the analysis and visualization of molecular docking. 3D structure of HIV-1 protease enzyme is downloaded on the WRCB-ORG website with PDB code 3NU3. Then BioFire Discovery Studio 2021 software was used to separate solvent residues, standard ligands, and other non-standard residues from enzymes so that standard ligand and enzymes bundle without other solvent and non-standard residues were obtained. After the standard ligand and enzyme are prepared, the redocking process is carried out based on the coordinate of the ligand-enzyme bond interaction using autodock tools. Then, an RMSD value of 1.68 Armstrong was obtained. If the standard ligand docking result has an RMSD value lower than 2 Armstrong, then the docking protocol can be accepted or declared valid. In this experiment, the 3D structure of the compound nigella and nigelladine for sulfite was obtained from the PubChem site, which was used as the test compound. Before molecular docking, the test compound is initially screened using Lipinski rules. Lipinski rules aim to evaluate a chemical compound that has a pharmacological activity that can be active if administered orally to humans. Molecular docking of the test compound was carried out using autodock tools with a grid box of 24, 34, and 24 Armstrong. The docking score value of each of the test components is then compared with the standard ligand docking score obtained from the previous redocking protocols. Based on the result of molecular docking of metabolic compound of the genus Nigella, the complex of nigelladine for sulfite has an energy binding of minus 10.42 kilocalorie per mole, and the nigella complex has an energy binding of minus 8.14 kilocalorie per mole, while the standard ligand Amprenavir has an energy binding of minus 12.6 kilocalorie per mole. Active compounds have the potential to be inhibitor if they have a lower binding energy value than standard ligand. In addition, inhibition constant were also obtained from standard ligand Amprenavir, nigelladine for sulfite, and nigella of 0.58 micromolar, 23.13 micromolar, and 1000 and 80 micromolar respectively. The inhibition constant indicates the potential of compound to inhibit the activity of its receptor. Specifically, a lower value of inhibition constant indicates the greater inhibitory activity. Nigelidine 4-O-sulfite has an energy binding value and an inhibition constant not lower than that of standard ligand. However, this compound still has the potential to be an inhibitor of SIV1 protease of the structure is modified by adding several function groups to this compound, which may be able to increase the interaction and decrease the binding energy and inhibition constant of HIV1 protease. BioFire discovery study 2021 was used to visualize a model of the interaction between ligands and protein after docking. Interaction that occurs in standard ligand with HIV1 protease enzymes are van der Waals interaction, hydrogen bond, and hydrophobic interaction such as alkyl and P-sigma interaction. In nigelidine ligand, there are van der Waals interaction, hydrogen bond, p-anion electrostatic interaction, and alkyl and p-alkyl hydrophobic interaction. In the nigelidine 4-O-sulfite ligand, van der Waals interaction, hydrogen bond, and alkyl and p-alkyl hydrophobic interaction occurs.
In conclusion, this experiment showed the potential of metabolite compounds from seed of plants of the genus Nigella using molecular docking methods, specifically nigelidine 4-O-sulfite as an inhibitor of HIV1 protease enzyme that can be further developed as an anti-HIV drug candidate.